So here I'm just going to work through the calculation of the standard deviation of a data set. So what is the standard deviation of this sample? So it's a sample, so that means we're going to use n-1, and it is, we've got a 1, a 5, an 8, a 10, a 16 and a 20, and these are all in millimeters. Right, so we know that the standard deviation is the square root of the variance, and we know that the variance is the sum of x minus the mean squared all over n-1. So first of all, I worked out the number of samples. There are 1, 2, 3, 4, 5, 6, n equals 6. I calculated the mean, which is 60 over 6 millimeters, or 10 millimeters. Good. So now I can apply this formula. So s squared is, so we're looking at the sum. So for each value x, I need to do x minus the mean. So in this case, 1 minus 10 squared. So that's for the 1. And then I do the sum of that, do that for each individual measurement and make the sum. So 5 minus 10 squared plus 8 minus 10 squared plus 10 minus 10 squared plus 16 minus 10 squared plus 20 minus 10 squared. Sorry for squashing that up at the end. And all that is divided by 6 minus 1, because n is 6. N is 6. Okay, so just let's carry on. So you've got minus 9 squared plus minus 5 squared plus minus 2 squared plus minus 2 squared plus 0 squared plus 6 squared plus 10 squared. All that over 5. So if we carry on, that is 81 plus 25 plus 4 plus 36 plus 100, all divided by 5. So all this is in millimeters squared. I'm going to come back to that idea in a minute. So let's write. Do you agree? Because we're squaring here. So the mean is in millimeters. Each measurement is in millimeters, but then we're squaring the difference here. Anyway, so this is 246 divided by 5, or 49.2. And now let's add the units, millimeters squared. So that means that the actual standard deviation is 49.2 millimeters squared, and we're going to take the square root of that, which is let's say 7 millimeters. And so standard deviation is much more convenient than variance, because the units are the same as the units of the original measurement. So that's a really good reason for using the standard deviation rather than the variance. Okay, so that's just an example of how to work out a standard deviation.